Welcome to qnawire.
So in this problem, we are supposed to calculate the probability of finding an electron in the ground state of hydrogen atom uh, at a less than 1 Bohr radius is 32%. So we basically use the formula for finding the probability, which is just integration of probability distribution times dr. Now PR is just probability density times 4 pi r square dr. So for ground state of hydrogen atom, we have equation 4 pi r naught cube square root e to the power minus r over r naught. So we basically substitute this wave function in the equation for P and calculate the probability of finding the electron. So P basically equates to integration. Now in this case, r goes from r is equal to 0 to r naught, since we are supposed to calculate the probability of finding the electron at a less than Bohr's radius, and so the upper limit is r naught and the lower limit is 0. And we have the square of the wave function r naught cubed times e to the power minus 2 r over r naught times 4 pi r square dr. Now this basically gives us, I'm just going to cancel the pi's, take out the constant out of the integration, and we have r equals to r naught e to the power minus 2 over 2r over r naught times r square dr. Now this integration can be made easy if we substitute for 2r over r naught by x. So with this basically gives us r is 1/2 r naught times x. So this gives us dr as 1/2 r naught times dx. Now when r is equal to 0, x is 0, and when r is r naught, x is 2, using this equation. So after changing the variables, we go back to the equation. So we have 4 over r naught cubed outside of the integral, and then the integration is now from x is equal to 0 to x is equal to 2. We have e to the power minus x 1 over 4 r naught square x square. This is basically r square, and then we have 1/2 r naught dx. This is basically dr. Now 4 cancels, r naught square and r naught cancels with r naught cube. So we basically have 1/2 x is equal to 0 to 2 e to the power minus x square dx. Now to solve this equation, we use integration by parts, and so the integration by parts formula is u dv is just uv minus integration v du, and here we have u as x square, dv as e to the power minus x dx, which gives us v as minus e to the power minus x. So we basically have e to the power minus x times x square dx for x equals to 0 to 2, as u is x square, v is minus e to the power minus x, and then we have integration of v is just e to the power minus x times we have du is 2x dx. Okay, so we basically have minus x squared e to the power minus x plus 2 times e to the power minus x dx. So x goes from 0 to 2. Now this equation, the solution to this equation can be found in appendix B, 6, integration by parts. So I'm not going to go over this term again. So we basically use it directly. So we already have minus x squared e to the power minus x here and plus 2. So from appendix B 6 we have the answer for this equation as minus x plus 1 e to the power minus x minus of x plus 1 times e to the power minus x. So we basically plug in that formula over here, e to the power minus x squared dx is just minus x squared plus 2x plus 1 e to the power minus x in the limits x equals to 0 to 2. So p is just basically half of this quantity e to the power minus x squared dx. So you substitute this here and substitute the limits and you basically get, so let me just write that one small minus of 1 minus x. Sorry, this is 2 x squared plus 2x plus 2 0 to 2, which basically gives us 0.32, which means the probability of finding an electron from at a distance less than Bohr's radius is 32%. Now in second part, we are supposed to calculate the probability of finding the electron between r is equal to r naught and r is equal to 2 r naught. So we use the same concept that we did, we just have to calculate the probability. So we have this probability density over here times 4 pi r square dr, and after going through all of the steps that we did for problem part A, we find out that the only thing that changes here are the limits. So in the previous case we had limits from 0 to 2 x squared e to the power minus x dx. In this case we have the limits 2 to 4. So we have 1/2. Since we have already solved this equation, e to the power minus x squared 2x plus 2 x is equal to 2 to 4. So probability comes out as 0.44 or 44%. So there's a 44% chance of finding the electron between R0 and 2R0 for part B. Thank you.